Thank you. Well, Happy New Year to those who are already in the new year, and very soon Happy New Year in 2020 for the others. Really happy to have all of you here. Apologies for those who already seen this presentation. I did try to add a few elements that we discussed last week, so hopefully it will still be interesting. For the wider audience, Habitat Marte, what we're doing during the missions is that we try to discuss what kind of bases we would need, what kind of centers we would need for a base on Mars. And to this effect, we each have to discuss one of the bases, and I was taking care of the engineering center. In this discussion, we discussed internal design, technologies that are necessary for the operation, resources, the organizational structures, so the astronauts, so what kind of profiles do you need, how trained do they need to be, what kind of videos you can find, what do they need for a week? I mean, they're going to eat and drink something, and you can use a 5-day basis to then calculate how much more resources they might need. Using this guidelines, you can then talk to the other facilities that you would have in the base, for example, the greenhouses or the power station, and give them guidelines on how to exchange with them. In addition, when you are operating on a base on Mars or even in any other remote area, you need protocols because you are in an unsafe environment. Space is one of the most extreme environments, and therefore you cannot proceed lightly in such context. But it doesn't mean that you can't be entertained, in which case we also have protocols for entertainment and 3D printing, and we have also the technologies that we could apply to Earth, like how do you develop something in space and then use it back on Earth. And additionally to this, how can you impact the sustainable development goals, okay? Because we are thinking also in sustainability. Space exploration does not mean anti-sustainability. There's actually a lot that we can learn from this. I also put the references, so if you have any questions or you want to know a bit more, you can always look at the end and have a nice read. Firstly, the internal design. So here you see, for example, an idea of what a base could look like on Mars, and maybe you'd have the greenhouse here, the power station. And let's say I've got the engineering center here on the side, okay? The ground floor would be where obviously you get in. So you would have 2 airlocks here, this one connected to the outside and this one connected to the inside. As a safety protocol, which we will also discuss later, you cannot have one open when the other is also open. This is to promote a safe environment and to avoid depressurization. You have mainly the engineering part on the ground floor. What makes the engineering center different to the others is that they have more technologies, they have more storage, they have more people that are focused on developing the technologies needed to produce the base. For example, creating extra parts, creating extra electronic pieces, repairing rovers, repairing spacesuits. This is obviously a very, how to say, schematic sketch. It would be very different. But one thing that we would need, for example, is fume hoods. When you do 3D printing, a lot of the material that you 3D print, specifically plastic-based, so ABS and PLA, they produce toxic fumes, and you cannot just produce them like this. You have to have this fume hood. But because you have a pump system here, so for the airlock, for example, when you go out, I would suggest to put a pumping system. This would serve basically to see if there's any hole in the spacesuit and save some of the air here. So imagine you get in here, it's normal pressure, and you put your spacesuit on, you depressurize it, and then you see right away if there's any leak on your spacesuit. It's much safer than realizing here outside that your spacesuit is has a leak, right? In addition, it saves this whole volume of air and then can be stored somewhere else inside the base. This pump would then be connected also to the fume hoods that are in the 3D printing and engineering center, and then will be filtrated. It will go through air quality control. Because you have rovers here, because you have people doing EVAs, you need an EVA control center, which is represented by those desks over there. You need people who are like aware of what's going on, who guide them, who have the maps, maybe drones even to look at, and a medical doctor. Here you can see a first aid kit and a toilet kit. This is again something we'll discuss later about the procedure for example, evacuation and safety. The second floor, first floor, depending if you say ground floor or first floor, has basically the kitchen, the vertical garden, a storage unit, as well as this gym. Why? So I put the garden here. Why? Because normally you have the air. If it has been badly filtrated, then it will still have a kind of barrage of vegetation that would help infiltrating a bit more the air. You would have all the storage of food and water here, and you would have the kitchen, and here on the furthermost away from the 3D printing area, you would have the gym. Again, this means that there's a bit more distance to be covered before the air can reach you. To try and stay fit, obviously it would be a bit more apparatus than these ones, but you would have cardiovascular as well as strength exercises available and a virtual coach. Maybe you want to do aerobic, you want to stay fit, you want to learn something new. You need to have those basically virtual environments, which can often simulate Earth and make it quite nice. It's not yet tomorrow that would be cycling on the moon, so it's nice to simulate, for example, cycling on Earth. And there's actually, and even more so since the pandemic, there's been lots of virtual worlds developed for use in sports. So you can run and cycle in virtual worlds, maybe even have a pool. And the last floor is basically the, how do you say, relaxed area. The living room would have also a music room. Why? Because music often stirs creativity. For the same reason, you could have a painting device here. I did not put it, but it's basically to say this is to increase creativity. In addition, you could have, for example, if your crew is mainly made of man, people who love music, then you could make a concert. Maybe you play a concert for Back on Earth, record it, and 23 minutes later, your family hears it. And you would have a relaxing room, you have a bit more private space if you need to call your family, record the session. And here, and as on every floor, you would have air monitoring, temperature, water quality. So every time you would have the whole information, but at the same time, it's not facing your couch. You would have an alarm if there's any problem. It's just you have this and you have your flight plan, but you're not disturbed by it when you try to relax. Obviously, there would be a bathroom, probably a bit more than one shower, probably 2 bathrooms would be better, whose water would be recycled. And the toilets could actually be dry toilets, where you have a separation of the water or like liquid and the solids, and the solid could be then used for energy, and the liquids would be recycled and used for the vertical garden and further processes. The bedroom would be painted blue because blue is a very calming color. It helps people stay a bit relaxed, and whereas orange is a bit more creative, a bit more, waking you up. And you could put curtains between the beds. Obviously, it would depend how many astronauts are actually on the base, but you could create a sort of intimacy by putting those curtains and help them feel more at home and not just in a base. So this intimacy is often very important. And yeah, you would have the space for it. Just a note about this. This is to scale. So this is an 8-meter diameter base, according to Google SketchUp, and all the equipment is to scale. So it gives you an idea of how many people you could put. Probably you could fit another bed here. So yeah, it's quite spacious. Now, the applied technology. So obviously engineering center, extremely important. So every center in the base would have 3D printers, but the engineering center would have a bit more. It would have also cutting tools, planing tools. You would have material to cut silicon wafers. Silicon wafers are usually used, for example, for electronics and solar panels. And you would need a white room for this, because when you print circuits, electronic circuits, you obviously need extremely clean environments, which is why you need this white room, plus the fume cupboards, which we discussed before, and the airlock rover EVA. But you also need some technologies that are very important just for the overall function of the base. So water needs to be recycled, used for cooking and the garden, and you need to have a quality control. As soon as you have a problem in quality, then you have a problem with your crew, or you have a problem with your plants, you might actually damage them. The air, obviously, Fume Hoods plus pressurization system for the airlock are quite standard. The air is quite easily filtrated. You can filter air from, for example, waste burning, and still have absolutely perfect air. So the system for filtration of air is one that is well known and not complicated to implement. Energy. So on Mars, the sun is not positioned in a way that you can have often constant and strong enough energy, solar energy. So you could do small missions, but to actually power a whole station is a lot. And also there's lots of sand, this dust, basically Martian dust, and this covers the solar panels, can damage them, and on the long run, it's not really useful. So one of the best sustainable options would be geothermal energy, depending on where you are located. So it wouldn't be applicable everywhere, same as on Earth. On Earth, depending on depth, it's just too much hassle to go that deep. But there are specific places that are okay for it. So it seems to be one of the most sustainable options. Nuclear energy would be the most efficient, but if you do not want to have the problem of waste, and also you have to think on Earth, we contain nuclear waste using water or using concrete or using some different, units. But there you're a bit more limited because you don't have that much structure, you don't have that many people, and you don't have necessarily all the material available. So you really have to think before you start, doing just nuclear energy. There was discussion during our mission 86 of using fusion reaction, but to get it started, usually you need a bit of energy. So you would need a nuclear fission reactor to then get started on the fusion reactor. So therefore, I think geothermal energy seems to be the most sustainable. In addition, although there are some earthquake, actually, I think this morning they measured a 4 on the Richter scale earthquake or Marsquake. So there are some, but usually most of the structures are quite stable because there's no tectonic plates. We'll see which one will be chosen, but basically these are two the main option. Regarding heat, so obviously one big thing that is important for humans, not only for comfort, but obviously for survival, is heat. And you can create a great installation, but you can also try to save some energy using human waste. Usually to do this, so as mentioned before, you separate urine, you separate the solid waste, and the solid waste have then some bacteria in it, and they can react, and then this produces methane, CH4, which you can burn and create heat. So this would be a way, for example, to keep the base warm and recycle some of the heat. So on Mars, there are sources of aluminum, titanium, magnesium, silicon, and iron. Iron is mainly found as iron oxides, and we're not 100% sure of each form of them, and this will then impact the mining and smelting of the materials. To protect against radiation, usually one really good thing is concrete, but concrete obviously takes a lot of volume, and on spaceship to bring it up would be obviously wasting a lot of weight on it. Therefore, one way to replace concrete or partially replace it would be to create cement based on volcanic ash that we found on Mars. There's lots of volcanoes on Mars, and they've already did some tests that volcanic ash works as partial cement replacement. The better we, improve this recipe, the less we need to bring material from Earth to Mars, and then would be obviously more sustainable, alone, more independent. The one material that you won't find on Mars is wood, because even if we create bases that have plants to actually grow a tree that would then be 20 meters tall and whose maybe volume you can use maybe a third or half of it, it would take years. It would absolutely take years. It would take massive resources, and it probably wouldn't work. So it would be something that you would need to bring if for some reason you would like to use wood. Wood could be usually used for maybe psychological reasons, just to give you a connection with nature that maybe plants are not sufficient. Other products that you won't find is petroleum-based products, obviously. So you won't have any plastic bags on Mars because you won't be able to produce them there. So these are the kind of thing that you would need to import if for some reason you think they would be necessary. But let's discuss again. So there's the problem of the material that you find on Mars. What do you do with it, and how do you do it with it? I apologize for the quality of the images is not amazing, but it's a good representation. So normally when you get iron out of a crust, the Earth crust, it's usually into iron oxide. And to remove this oxygen from the iron, you use carbons. You usually use what we call coke. It's not cocaine, it's coke. Not the same thing at all. And basically, you reduce and you have several reactions, and then at some point you produce CO2 and iron. And on Mars, you would need energy for this. You would need to bring coke. You also would need oxygen to stabilize. Sometimes we also use hydrogen to improve the reaction. So we'll make it quite complicated and yeah, not necessarily something that will work. Because we are working into sustainability, however, some people have started to work into a CO2-free iron production that you see on the right. You can use, for example, solar power to use this technique. You put your iron ore, so Fe3O4, Fe2O3, so those oxides, you put it into a molten lithium carbonate bath, and it works as an electrode deposition, and you put two anodes and cathodes in it, and then you create a current. So for example, solar energy or geothermal energy or nuclear energy, and basically you get a separation of the iron, the oxygen, and then you get your iron. So this is something that we could use. Obviously, one of the reasons they wanted to use this technique is to reduce the CO2 emissions, which is something that we need to do on Earth. But on Mars, we actually want a greenhouse effect. So we will see which solution will be extracted, but this one is probably one that is easier to control and would take way less space. So if we manage to create lithium carbonate, it would be then quite easy to use the solution to extract iron. In addition, apparently the iron oxide that we found on Mars is quite clean, so it would be quite easy to use this iron ore into this process. Other examples of mining and smelting, so you really have to think all the resources that you have on Mars, you can't necessarily get them out as easily, right? And one aspect is water. So we know that there's ice on Mars, which is really great news, but it's often kind of mixed into the dust, into the crust, okay? So you can't just put your finger in it and lick it and then you get water, right? It doesn't work that way. One experiment that we did this summer as part of the space mission Asclepios, we worked with the MIT on Project Hydration, is you use a drill that you control remotely, and it drills the soil and it removes basically the water. How? Because it melts the water and it extracts it. This would be a nice way for us to have water that is produced on Mars, or at least found on Mars, and that we would need to import from Earth or recycle from our UN. So this is one thing that we've been testing. If you want to have more information, you can check this YouTube video. I will send you the link at the end. They also worked with the Igluna campaign. So it's quite interesting technology. In addition, also aluminum. So you have to think that the gravity is not the same on Mars as on Earth. On Earth, we try to use materials that are extremely light. And the reason for this is because the gravity is obviously quite high. Compared to Jupiter, it's not high. But still, obviously, our planes, even our cars, we're always looking for material that is lighter because it means that it would consume less. But on Mars, obviously, it's not as bad as this because gravity is a bit lesser. So we could, for example, say, well, we can use steel where we used to use aluminum because it has a lower density than steel. But aluminum actually might be used for other uses than on Earth. The one thing would be, for example, batteries and windows, as well as electronic like conductors, because we won't be able to find copper on Mars, or at least we think we won't, and gold would be another conductor and might also not be found in high enough quantities. So it's funny to see that on Mars it's more structural, on Earth it's structural, and then on Mars it would be for a different application. Just so you know, the way we produce aluminum on Earth is we found aluminum as Al2O3, aluminum oxide. It's extremely stable. It's very corrosion resistant because of the stability, which makes it really, really difficult to extract into pure aluminum form. To do this, we use hexafluoride, which is a greenhouse gas. So we melt it and we put the aluminum oxide in it, and then basically we manage to get separation. And this was a massive problem with this gas because obviously we're heating up the atmosphere on Earth. But again, in the same process as in iron, we might think that on Mars it could be useful. So we'll have to see what we do, and it will also depend on the form of aluminum that we find. If we find only small particles on the crust, maybe we'll think, okay, well, maybe it's not really worth it, and we'll just import some gold for connections. And for any construction, we'll just use steel because steel is predominant on Mars. So this is just to give you a material science point of view. I hope it's clear. Otherwise, just fire any question. I'll send you the links. Now, obviously, to operate all of this, you need a team of astronauts. You need to understand how they manage each other. So the organizational structures, usually you have a commander, and then you have the base engineer, science officer, communication officer, and health officer. Obviously, because you have an engineering center, you would have quite a few engineers that would work with the science officer and producing everything. So all of them have these roles, but they also all help in the production of samples. You're not just commander giving orders and then going for an app. No, everyone is doing everything and helping. They just have also specific roles additional to these. The commander, what do you need in a commander? You need to have high empathy. And the reason for this is because your crew's health will impact directly the mission success. If you cannot read if your crew is feeling unwell or stressed, then you might have a problem. And you need to be able to connect with them, and you need to help guide them. One way to guide them is to also lead by example. You can't just give an order and say, okay, go clean the toilet and not do it yourself. You have to do it, because otherwise then you can have a mutiny, or people might not understand why you not doing that thing. You are a team together. The commander is only there in case there's a problem, okay? You have to be a bit proactive and organized. You have to see where there might be a problem. The mission, for example, you see there's not enough food, or you see that there's a problem with one of the devices, and you signal it and you're open. You also have to be extremely calm and efficient in case of danger. This is the most important part as a commander, is if there's any problem, you will have to take the lead. You will have to bring your crew to safety. And if you are panicking, if you are anxious, then it's not going to work. Obviously, most astronauts cannot be panicky or anxious. They have to be trained to be obviously calm in face of danger. But it's even more so for a commander. You cannot have somebody that is a follower in the place of a commander. That doesn't work. They need to be able to take charge and feel responsible for the crew. The task of the commander is you have to relay daily activities to mission control. So basically, you're the one also making the link and just checking with the rest of the base that everything is fine, and often with Earth. You take care of the mission, the crew, so you are proactive, you see if anyone's feeling bad, you see if there's any problem, and you react, okay? Like, you just think on your feet and think, okay, how am I going to solve this already now, before it really happens? Take charge of evacuation, as mentioned, and also you check the air, water quality, and you also relay this to mission control. This is pretty straightforward, and as I said, normally you don't have that much to do unless there's a problem. The base engineer, usually it's good if they have a strong engineering background and are resourceful. So if they are not used to working with machines, like you can be more of a theoretical engineer, more a scientist, that's not really useful. You need to be able to repair anything from the toilet to the pumps to the garden water system, even the kitchen, that you are responsible for the base integrity, okay? You have to control the systems every day, and you have to report to the whole team, not just the commander, but the whole team, as well as Mission Control Center. This helps in bringing transparency in the crew, trust, but also so that others can help you as a base engineer if there's any problem. The science officer obviously has to have a very strong scientific background, and preferably multidisciplinary. The reason is, for example, if you just a biologist, maybe you won't understand some electronic testing, or you might not understand some materials testing. The same as if, for example, you're a physicist and you've never done biology, maybe you won't understand the implications of some of the experiments that you are doing. So it's better if you've did science in some different backgrounds and you've done research before, because most of it will be pure research. So it's very important to have this open-mindedness, being curious, and also be extremely, disciplined and very clean, okay? You cannot botch an experiment. Some of those experiments will have been sent from the Earth, and you really need to take care of them. You do have to check on the progress of the experiments. So obviously you have to write protocols and verify them, look at the devices, ask maybe the base engineer if there's a problem with something, and then you also have to communicate. A lot of space love and space money comes from us scientists communicating to the general public, for example. And one way to do this is by doing this presentation and explaining some of the scientific experiments that are made. So this presentation part is actually very important. It's not just about being in the lab, it's also being able to transmit these results. Now, the communication officer, background in communication and computer technology is quite useful. They will be responsible for communication checks with Mission Control Center and doing the EVAs. So they will, for example, in the morning, they will get up and they will do the link checks with the Mission Control Center. They will check walkie-talkies, they will check alarm system, they will check all the computers for connections, storage, backups. Obviously, you have to also save all the data that's produced. If one day you lose all the data generated and has not been sent back to Earth, then you've wasted an extreme amount of resources and time, right? Because you won't remember everything necessarily. Because there's no words on Mars, there's also probably not that much paper, right? So the electronic form of thing is extremely important, which is why backups and storage is extremely important too. Obviously, the communication problem is also the most important one. If you can't talk to Mission Control Center and it's an emergency, then it's very bad. You can't just pop in a spacesuit and just go out and knock on the door and see what happens, right? The communication part is really crucial. And lastly, a health officer. A health officer, obviously a background in medicine is necessary. And a backup to the medical officer is also needed. The reason for this is if your medical officer is injured, then nobody else can treat the crew. Even if the whole team gets a first aid training, they won't be able necessarily to, I don't know, repair the insides or amputate an arm. You know, these are the kind of thing that you ask more advanced trained people. Therefore, having a medicine background is really good, and also receiving a first aid and advanced medical training for extreme environments. Medicine in extreme environments is not necessarily the same as in a hospital. You don't have the same tools, you don't have the same machines, you don't have the same personnel. So you have to make decisions a bit differently. You usually try to save somebody's life rather than try and save their fingers or their arms, right? And you don't have access to the same medication. Therefore, this training is very important also so that you as a medical officer can stay calm and not panic and think, oh my God, I'm just going to call my superior. There's no superior. You are the superior there. So you have to make this decision, basically. In addition, the health officer has to be on standby doing EVA. So when astronauts go out for an EVA, they have to be in the Mission Control Center, well, the communication room for EVAs, and there will be one Mission Control Center, and they are in contact with the astronauts. Why? Because they can provide urgent help. For example, if one astronaut's full, then you need the other one to say, oh, okay, health officer, I need help. This person fell. What should I do? And then you give them basically the task they have to do. You see if it's critical. You see if they can keep on doing the EVA, etc., etc. So they have to be there. Now, what kind of training do astronauts need? Obviously, you have survival training, not only so that you learn how to survive outside of the base or on Mars because it's an extreme environment, but also so you can really keep and get confident. The first time you maybe do some diving or skydiving, you think, oh, it's nice, but maybe you're a bit stressed. And once you've done it 100 times, then you know what you do. You think about your procedure and you think, okay, well, that was a bit risky, but I know I have this protocol, and then I'll be fine. And this confidence is very important so that you stay calm and you save lives. In addition, you have to have team building and team psychology. If you're somebody who's not really open to psychology and you're not really interested in others, you won't be able to fit in a crew. You cannot be completely remote from the rest of the team. Why? Because it's a very small space, there's not that much intimacy, and you need to get on well with the other crew. The mission's quality will depend on the team. In addition, you also need a leadership training. If your commander is not there, is ill, is injured, is dead, and sadly that can happen, hopefully not, but it can happen, somebody else will need to take the lead. And therefore, the vice commander will be elected, but you will also in yourself need to take this leadership. Leadership also helps in being more independent and taking more initiatives that can then benefit the mission. Science training, base engineering training, communication training, all of the engineers and astronauts on the base will need this training. Why? Same thing. If the base engineer is not there anymore, you still need to be able to repair part of the base. It won't be as quick, it won't be as efficient, but each astronaut needs to be able to do this. Every position has to be redundant, basically. Public speaking training, as mentioned before, it's very important to communicate back to Earth what is being done on Mars. And if you can't do it in an elaborate way, if you can't speak that well, if you're very shy, then it will be a bit problematic. And it's nice if each astronaut can talk and not just the one person who talks a lot. Cooking training, I put it in the program because it's actually quite important. Cooking for some people is important, for others it's not. But in general, food plays a really important part. We are animals after all, and we love having a good meal, and you won't necessarily have always that many fresh products. Even food is a greenhouse, you won't have the same diversity on Earth, and that can put an impact on your mind. And if in addition, one of the astronauts who's cooking cannot cook pasta to save their lives, then you're going to have a problem, right? So you need to give this basic cooking training also for safety so that you don't cut your thumb. It sounds dumb, but you're really, really far away from Earth and you need to have as little injuries as you can. So this cooking training are extremely useful too. And obviously, health and safety training, first aid, evacuation, hygiene. Hygiene, you don't think it's important, but actually it is. If you don't clean yourself enough, if you don't clean your tools after cooking, then you can have the development of bacteria and then you can fall ill. And if the whole crew is ill, then you can actually compromise the whole safety because there's maybe nobody to check the air or the water quality or help repair things. And this is obviously not something you want. So this hygiene part is also extremely important. Not to mention that you wouldn't be happy having a crew member not taking showers or at least not doing the proper hygiene. If you start to smell in such a small environment, then you will be affecting others, and it's not something you want to do. Even if you have the best team building and best team psychology training, take a shower or as close as a shower as you can on Mars. YouTube videos, obviously those videos, like it will depend on the base. For example, I think one of the most important videos that will be virtual reality videos where you imagine being in space in your base and you know exactly where you go and where's everything. This is something, for example, you have for the ISS. If you have Oculus Rift, you can see the ISS everywhere. And if you do a few trips in there, then you know exactly where is what and where to find which tool and which airlock is which. It's really, really important, and it will help, I think, people in the future be more efficient in the base without spending too much time on it. You don't need to train necessarily in an underwater facility. You can just train with the spiritual reality. Psychological videos, obviously, just to be a bit more understanding. Workouts, there's so many workouts. I just gave an example of the workout I can do with the University of Cambridge, but there's so many of them. And meditation is obviously some of the trainings you can do. There's every time you're interested in something, there's a video on YouTube. So I won't be giving my favorite ones. It's up to each and every one of us. Resources needed for 5 days. So water, I took the values of 70 kilo male or female. These are more or less the values in between. And I took the maximum for the carbohydrates, proteins, and fats. This gives you basically an idea of what you would need, but it doesn't tell you how happy it will make you. For example, you will need a bit more food if you're usually male, and if you're taller, and if you're more active. Why? Because you have a higher muscle ratio, and these use a bit more energy. In addition, they will also use protein. If you take all those contents and you have them in the base, then you can adapt the cooking according to this and according to the crew's metabolism and hunger. You shouldn't force the astronauts to eat too much or too less. But by doing an inventory, you also know if they are not eating enough. And usual regular health checkups will also tell you if an astronaut is losing weight, where you can then monitor their intake. Those resources are just useful to have an idea of how much you will need. In addition, this will vary depending on the temperature of the base. If you have a base that has a normal 21 degrees Celsius temperature, then you're fine. This is a normal metabolism. As soon as you're a few degrees under this, then your metabolism will go up and 200 calories a day doesn't seem much, but if you multiply it by 5 days and then by each astronaut, it becomes a lot more kilos of food that you need to bring. So this is something that needs to be taken into account into your calculation. In addition, if you have a crew of, say, 6 females of 60 kilos, they won't need the same as 6 males of 85 kilos. So this is where you can adapt. One very important part is something that we don't say exactly here, but you will need vitamin C and mainly vitamin D. Vitamin D comes from the lack of direct sunlight exposure. And some people need more vitamin D than others. It usually depends on the color of your skin or some things in your skin. For example, they would say that ginger people do not need that much vitamin D. And you will need this because otherwise you will have a bone infection, even more so because of the reduced gravity. In addition, you also will be more tired and perform less and be less focused, and then that will have a direct impact on the mission. So everything linked to vitamin D, but also oligo elements, just as iron and iodine and sodium and magnesium, will all have to be checked, and supplements will have to be taken just as a safeguard, basically. An example of a menu, this is something that we had during our mission this summer. You can, for example, do coconut and cranberry oats, and then at midday you eat a chickpea salad, in the evening pad thai, and the next morning you can make pancakes, and you can use planted chicken. Planted chicken is a vegan version of chicken. It's very useful because obviously you won't have the space on Mars or the moon to have chickens and cows. Why? Because you need a massive surface of grass and corn and other plants. And we barely have this for humans, or we will barely have this at the beginning. So you won't be able to feed other animals and then eat them. So one way is to simply have a vegan version of it that you can create using, for example, soy plants. And then you have a very analog meat, basically, on Mars. All these foods are easy to do, and they really cover all the needs that you can need. For example, the protein drink can help and overcome the lack of meat for better protein absorption, and it can also help when being taken after a workout to increase protein absorption. So this is something easy to drink, easy to prepare, still delicious, still viable, and it can all be put in tin cans or in containers. So it doesn't need to be 100% fresh to be good. It's all things that you can find already locked in and can stay there for 20 years and still be good. So it's pretty amazing, pretty variable, and absolutely perfect for the crew, in my opinion. Well, at least that was my opinion when I had this summer. So, guidelines for the other facilities. Obviously, when you want to come to the engineering center from another facility, you can't just knock on the door of the airlock and open it and get in, right? So the best thing is to plan a visit or by communicating it using the flight plan. So for example, the flight plan of each astronaut, you know what you have to do, and then you know, okay, at 10 a.m. we're going to have a visit from, for example, the power station, or we're going to have a visit from that person. Once this visit is announced, then they, when they come there, you do radio communication with them. When in front of the airlock, make sure that the indoor airlock is closed, let them in. Same in an announced visit. If they try to do this not nothing, they have to make contact via radio, and then once they have the go, they can get in. And once they get in, they should do a quick medical assessment. It's not because maybe they fell and tripped and they hurt themselves. It's because if they have, for some reason, a disease, they might contaminate the rest of the crew. This is why you have a first aid kit in the airlock. It's not only just so that you can save people quicker, it's also that if you have an exterior visitor, then you can do a short medical assessment, do a temperature check. I mean, we've seen these with COVID. You just, have a laser pointer and you see if there's a temperature difference. And then if you see that everything's fine, then you let them in. There's even a toilet if they need to wait, absolutely no problem. But it's obviously a way, again, to protect the rest of the crew. So the protocol, so the routine is, for example, a health check of the crew. Every day, you just, ask the crew how they're feeling, and you take their vitals. For example, their blood pressure, their pulses per minute, their oxygen saturation. For example, oxygen saturation is extremely important to know if you have good lung function or if you're, for example, getting sick, as well as your temperature and your blood pressure. It also tells us if you are stressed or, for example, eating not really healthy. The daily communication link check, obviously done by the communications officer, daily base check by the base engineer, inventory and quality check. This is also very important. The inventory helps you in knowing if you have enough resources to do your engineering, but also for example, plants, do you have seeds left, or food? Do you have enough food? Or are you going to run out of pancakes, or is there anything missing? This helps in knowing if there was a mistake when you went to the base, or if somebody maybe is eating too much or not enough, or if something is lost and you need to find it. You're not going to have that many spares. You're not going to have 20 extra pancake plates. You're not going to have extra glasses. Even if you can try to make some resources will be really limited, and having one missing is not really that good. In the International Space Station, they had, I think it was an electric drill that was missing for months because it just floated away and hid behind a pillow or something like this. And they found it, I think, months or even years later. So even there, they've missed things. So you have to make sure that they're really where they are and check them and make sure you're not missing them so you can keep on working efficiently. Daily base cleaning, this is part of the hygiene protocol, just to make sure that there's, for example, that nobody gets too dirty. So there's no conflict because of a dirty base. Just make it a protocol. And additionally, it's just also to keep you safe from bacteria and any other problem. There will be a team briefing in the morning where you get your flight plans, you know, to ask people how did you sleep, how are you feeling about the day, share about the experiments, and in the evening you have a team debriefing. The team briefing is also done with the Mission Control Center, and this is to help make sure that the whole mission is still on track and notify if there's any big thing coming, for example, a visit from another center. The team debriefing is more to make sure that everything was fine, see how you can improve the next day, and just kind of do your closure of the day. After this, you can go and call your family or have a music session or just relax. The protocols of safety, you will have fire alarm. Obviously, a fire alarm is obviously extremely dangerous. You can be really, really scary if you're in a base like this, because it's not as if you can go outside like on Earth. You would need to put a spacesuit and then go outside. And there's also the problem of integrity damage. So if your base is not insulated against space and against vacuum, then you're going to have a problem. So you would have alarms for this that will ring, and all personnel should evacuate to the airlock. Why the airlock? Because the airlock would be made of a reinforced material, and it's very unlikely the airlock would be damaged. In addition, the airlock would have a toilet, the first aid kit, and spacesuits, which would then allow you to go outside. There will be a walkie-talkie also connected to the base so that you know if it was a phase alarm or if there was any problem. And for example, you can decide to evacuate the airlock if it's not caused by, for example, a Mars quake or any, for example, solar flare or dust storm. If it's something internal, then you can also go back and you can just put your spacesuit and check the integrity of the base, see where the leak happened, where's the damage, etc., etc. You also need, obviously, the air quality control, but also radiation levels, and you have to report them. If there's, again, a certain level of air pollution that is reached or radiation, then you again evacuate and control the system. Food and water should also be checked. So this is when you do the inventory, you should check that the food is, for example, not moldy, it's still safe to eat, so that nobody gets sick from this. Protocol for occupancy, again, Brazil, Olympic Games, because I thought, well, you know, what could be fun is, as part of the sports for the members, would be to do mini Olympic Games. And that could be something to entertain people. Usually astronauts are quite competitive people because you have to do such a strong job. You need this kind of mindset. So mini Olympic Games could be one way to keep them entertained and have a good time while still making them fit and, you know, in good health. Weekly movie nights could be a thing, as well as wellness activities such as meditation and massage. And massage would also help you keep contact with, you know, normal human contact. And then there would be family time and external communication, and there would be a library, music, and movie database. This is for entertainment, but also you would have educational resources. Even if you would be learning a lot and working a lot in space, sometimes you also want to learn something new. For example, imagine one of you astronauts is from a different country and speaks a different language. Even if you talk together saying English, maybe you want to learn their language. It's really nice. And having access to those educational resources would be a way to think about something else and learn something and feel at home. And there would be virtual reality sets, as mentioned before, so just for the base, just for escaping, in other words. Protocols for food microproduction. So I suggest the use of robots for monitoring plants. Why? Because it's really easy to overlook if a plant is humid enough. If you don't have the green hand, as we say in French, sometimes you don't realize that the plant actually needs more humidity, or this one needs less humidity, and you could potentially kill it. And a robot will help in monitoring this. However, I think it's really important that humans should also be taking care of this plant, because it creates a really good reaction in your brain when you see green leaves in nature. It's also a way to stay connected with Earth. Also, having plants with strong smells, so herbs for cooking, would make cooking obviously more comfortable, but also would stimulate senses and, just trigger positive, signals in your brain. There you have an example of the Grobot Hub for Igluna mission. We were supposed to use it for our mission too, but it's quite complex, and basically it just monitors the plants and it just tells you what it needs to do. And at some point, I think it will use human waste you take human waste and you use it to fertilize the plants. And if you can use a robot for that, it's nice, because then it means you don't smell the human excrement. You just smell the nice plants once you picked it up. So have a look at Robot Hub. It's quite interesting what they're doing. Protocols for 3D printing. Before 3D printing, you need to do material inventory so that you know what you have, and then you do the design. And design has to be approved by both the base engineer and the science officer, just to make sure that both from a scientific point of view and an engineering point of view, it's feasible, you have enough resources, and you're not wasting anything, that it's actually worth it. In addition, if you're printing, for example, a part for the exterior of the base engineer needs to tell you, well, actually, these are not the right dimensions. You would have to put the fume hoods on, again, just to make sure that you don't have any toxic air and it's being filtered. And if you do 3D printing of Martian soil, which is something that is being sought, you should document it really, really strongly. Why? Because we're trying to make it work, and it would be amazing if you could create habitats only using Martian soil. You would save an immense amount of resources that you need to bring from Earth to Mars. So what can you apply to Earth? Well, integrated water recycling facilities. I mean, if you have water in a closed loop and you manage to do everything you do with this without importing any extra water, it means we're not going to run out of water. Obviously, something that is extremely important. The heat management of buildings, obviously that reduces energy waste and just energy production. You wouldn't need that much energy simply because you would be better insulated. And going to the loo would help you warm up for colder nights. Quite useful. And the use of vertical gardens. Obviously, vertical gardens, they filter the air. A lot of cities now are actually prone to pollution. And having those gardens would improve the air quality, provide also psychological help, and bring a bit of delight in cooking, and obviously healthier food. So these are easy technologies that you can put into place. But also, you can add things like meditation just for well-being and better communication. Even a briefing in the morning and deep brief in the evening is something that you can use quite easily. And what should you apply as guidelines? Respect one another, make quality work, and do more with less. Obviously, the respect one another is something that seems quite straightforward, but it's not something that we do well enough. And in every way, you could profit from working as astronauts and with respect and trust and just, improving. And this would then improve your work quality. In addition, if you learn to do more with less, such as, well, you have this little amount of water and you manage to live in an autonomy in a Martian base, it's really amazing. And if you can, you use the material that you find and just repair them instead of buying things again and again. It's also extremely important attitude and something that will make you, I believe, a better human being and also more sustainable. And speaking of sustainable, what are sustainable development goals that could, for example, be reached with this engineering center? So obviously affordable and clean energy, if we can get geothermal energy, then it's amazing. Then the innovation infrastructure, if we manage to develop what I was talking about, the mining and the smelting of aluminum, iron with a more sustainable alternative, where we have no greenhouse effects on Earth, that would be amazing, because it means that we have less greenhouse effect, but we can still use those materials to build our homes and make sure people are safe. Sustainable cities and communities, again, if you live in an independent base, then you learn how to live with this, and then we can implement this technology back on Earth. And then lastly, responsible consumption. When you're an astronaut and you have to do an inventory, because otherwise, you're not going to have enough water or enough food or enough energy, then you learn how to be a bit more responsible. And it's something that we can really, really apply on Earth. We would have really enough resources if we were just a bit more careful about what we do. So these are quite a few goals that we can just reach with our Martian base and what we can learn. And we can also learn new technologies for all processes, instead of thinking, well, for example, iron smelting, it's a very, very old technology, something that we've been a bit improving, but it's still not sustainable. But well, if we can find a sustainable option, develop it on Mars, then we're like, okay, well, we manage on Mars, surely we're going to be fine on Earth, and then we can really improve the process. These are the references. I'll be sending the slides, so have a look at them. There's a few others that I can also send. They're really quite interesting. And if you want to contact me on any social media, these are my credentials. I hope you enjoyed this, and a happy new year to all of you, and stay here for any of your questions.